One of the ways, and actually I should say one of the easiest way that you can cluster is with K-mean cluster. Like for example, you said I want 10 clusters. Then K-mean is going to take 10 points and put it in different sides of your data set, in the middle or on the side, it doesn't matter. Just randomly put 10 points, and these points are called centroid, distance between each one of the data points and the points that we talked about, which we're going to call it centroid. It's going to measure the distance between them. Each one of these centroids will go through all of the points, and they're going to measure the distance. All of these data points have to be assigned to a centroid. And each one of these data points pick the centroid that is closest to them. If one of the points is close to one centroid, another point is close to another centroid, but these 2 points are very close to each other, it doesn't matter. One of them is going to get picked up by this centroid, and one of them is going to get picked up by the other centroid. I think you can already see the problem in K-mean. So these 2 points that are very close to each other and very clearly most likely have to be in the same cluster are going to be assigned to different clusters because different centroids, they pick different centroids. Now that each one of these data points is assigned to their own centroid, these centroids are going to move and place themselves in the middle of the points that have picked them up, right? The points are not going to move, the centroids are going to move in the middle. Now imagine, we have points on one side of the data set and the other points are so far away. Those far away points are getting picked up by the centroid that is far away from them, but it is the closest centroid to them. What's going to happen? Those points that are far away are going to drag the centroid, because centroid have to be in the middle of the points that it has picked up. This centroid that has picked up those far away points is going to be dragged all the way there. Okay, so when it is dragged all the way there, these points that it picked up initially are going to be far away from it. Okay, and they are going to be close to the other centroid that didn't move that much, right? So after the move, there is going to be a reassignment. Each one of these points, again, look around and find the closest centroid to them and pick that centroid. These points keep going to move around and reassign, move around and reassign until one of these conditions are met. Centroids are not going to move around anymore, or there's no reassignment anymore. It's done. It says, okay, it doesn't matter how many more time you want me to repeat this process, it's going to be the same thing. There's no more reassignment. And another thing is when you have set a number and you say, I want you to move around, for example, 10 times. If you couldn't figure out in 10 times, then just let it go. And these centroids are just chosen randomly. They can either be very close to each other, or they can be so far away from each other, or it can land in the middle of 2 clusters. But as you can see, there are going to be multiple problems with this. If 2 centroids are very close to each other, they might separate a cluster, which is clearly one cluster, into 2 clusters, because one of them is close to certain points, one of them is close to other points, and they are going to separate one cluster in 2 clusters. Another situation would be that this centroid has landed between 2 clusters. So now the problem is that it might consider these 2 clusters as one cluster. It measures this point and say, okay, I'm in the center, so I don't need to move around anymore. But it is actually in the middle of 2 clusters, and it is considering these 2 clusters as one. So these are some shortcomings with K-mean. These 2 problems that we talked about, and the problem similar to this. So as you remember, we talked about initially choosing random points, and sometimes these points were very close to each other, so they could actually separate 2 clusters. One of the ways that K-mean++ is tackling this problem, first, it will choose the first centroid randomly, and then it's going to measure the distance between this data point and every other data point that is in your data set. And then it's going to choose the one that is farthest away as the second point or second centroid. And then the third one is going to be the farthest away from these 2. And just like this, it will come up with all of the centroids that you wanted, or the number of clusters that you asked for. Say is, if you actually know that you're choosing your centroid far away from each other, the chances of you getting distinct cluster is more than just randomly popping up these centroids and some of them be very close to each other.